Welcome back to Mr. Lamb Science Corner. Today we're going to look at something that is most properly called the four-color map problem. It's an exercise in topology similar in many ways to the Möbius strip that we did some time ago. If you haven't looked at that yet, that's a good one to look at. Put a little advertisement in for myself. I don't call it the four-color map problem, however, because what I want to do is challenge the student to try to find out how many colors have to be used in drawing a map with the rules that I'm going to give you in just a minute. And if you call it the four-color map problem, that kind of gives the answer away. So don't do that. I have drawn here a map that I've used for years. Anything that you want to draw, I like using straight lines just because it looks kind of cool, and you can draw however you want. But the rule is that two different sections, let's see if I can use a pointer here, two different sections cannot have the same color if they meet on an edge. If they meet at a point, like down here, this one and this one may have the same color because they only meet at a point. But this one and this one cannot because they meet in an edge. And that's really the only rules that you have. You want to encourage the student to use the fewest number of colors possible, because when they print these things, basically, I don't know if they still do this, I hope they do, but they run through the printer and the maps and such that they're doing offset press and all this other stuff, and they have to run it through each time for each different color. And so the more colors you use, the more costly the map. So most people want to minimize the cost, so they want to use a minimum number of colors because minimum times they go through. So anyway, so just draw any type of design. If, like I said, if you don't like straight edges, you can draw like this. But if you draw irregular shapes, getting them to see that it comes down to a point sometimes is a little difficult. Okay, right here, this one and this one meet at a point. So this one and this one could be the same color, but this one and this one are different colors. And the same way here and here. Okay? So if they meet at a point, so you want to do that. And now if you want to get really fancy, if you want to draw this on a donut, then it becomes quite a bit different. And I have been told that on a donut, a toroid, if we want to use the technical term, it requires 6 colors. So that might be a little more expensive to do, because this one I made up 30 years ago, something like that, and I still got copies here. So God bless Xerox or something like that. So anyway, so the map problem it's an introduction to the study of topology, and it can get very strange and this problem is appropriate for all students. If you want to go further, then it would be probably a tag thing that you'd want to do, especially for elementary students. So anyway, four-color map problem, just call it the map problem. Challenge them to figure out the smallest number of colors needed. Okay, thank you very much.